Carbon nanotubes and carbon composites can allow us to make much stronger building materials. And in some ways, I think this will lead to a better foundation, um, literally for buildings, which will let you build buildings that are more stable in natural disasters, fall down less, taller buildings, um, and much more cheaply. And will also let people live more in the city close together instead of taking up as much land. And also this construction cheaper. How do I think it'll do this? Well, a common way of building foundations for building, and you have to build a foundation because the soil itself is unstable and cannot hold a building, is to take giant pylons or kind of imagine giant walls and pound them in the ground. And the deeper they go in the ground, the better, because then they can get soil away from the freezes and stuff that doesn't freeze or get water or is not stable. The more weight they can spread out deeper onto more soil, better. But also there's a bunch of other advantages in that if they're deeper, you can make it, you don't have to take up as long, you can put some of the force more in the soil and you don't have to make it as wide. Bunch of advantages like that. If you can really hit the bedrock, it's the best. And it's oftentimes cheaper than digging out a giant hole and filling up with concrete. And for the same amount of material, you can actually make a more stable one, because all that concrete is not putting the weight into the soil. Only the ones at the side edges and the bottom, only the surface area. So that's just a brief overview about the most common method and some of the easiest methods. Not the most common, but one of the most common. So one thing that a stronger building material could do, and we're talking about a couple 100% stronger than existing ones, made with carbon composites, is that you can make the piles you put in thinner. Now a thinner thing that you're driving to the ground has a couple of advantages. One is it's really the surface area of the thing that's really spreading the weight out. Because remember the surface, because it's spreading into soil, so it's not the whole volume is taking up, it's a lot has to do with the surface area compared to it. And if you have multiple smaller ones compared to one big one that has the same volume, you can spread it out the stuff a lot more, because the volume, it goes by the surface area is pi r, 2 pi r, where r's radius, so sometimes divided times the height. Well, volume goes with pi r squared divided by 8, so it goes up much more rapidly. So when you make it bigger, you lose about, with the radius, you lose about the radius size of ability to transfer weight into the outer surroundings. And it's all about the surface area. And then if you have 2 with half the radius, it acts almost better than a bigger one. And you can space them more evenly out. And there's also, if you can make it if you can make it go deeper in, you more likely hit stable layers of soil or bedrock. And it's more stable because it has to move more soil. Like a lever, the deeper it goes in the ground, the more it's going to act like a lever arm. So imagine that you have a lever. If the lever arm is this, if it's tilting 45 degrees, that's a little bit. But now if it's tilting a lot, it has a lot more soil presses against. It's going to be a much bigger change along the radius of it. It's going to be swinging proportional much more to the radius. So you have that one, a lot more force there. And you more likely hit more stable soil again. You can also put seismic sensors in this thing to get on this idea about earthquakes and seismic data for all around and for your building in particular. And the deeper you go in, the better seismic data you can get. And also when you're pounding it, you can get some sense of the seismic structure by how the vibration stuff travels. And the deeper you get, the better data you can get. I talked about how the pressure is even more, but it's also easier to pound it deeper in. And what I mean by it's easier to pound it much deeper in is that this whole thing, now that you're pounding it, it is so much more, how would I phrase it? thinner, and a thinner thing is easier to pound in because each time you're hitting it, it pushes less soil apart in each one. It's like a thicker nail is hard to pound in this thinner nail, so you can also pound it in deeper in that way. And you have the advantage then that it's less like tiller because it's pressed against more soil, again with the rotation, and it's more like you hit a stable layer, and it's more easy to put more marble ones in. Another huge advantage of this whole system that I want to mention is simply that it is, how would I say it? It is lighter. So that means that when people are trying to build these structures, it becomes a lot easier to transport and handle. And that can make transportation cost less, which is better for the environment, better for building construction. It can make it safer to handle. The heavier something is, the harder to handle. The easier it's to line it up and manipulate and move it. And so on. So just making stuff lighter and thinner is hugely advantageous. Another one is that if it's lighter and if it's less thick, it's easier to rotate. The wider the circumference is, the harder something rotates, and you can feel the force with it, and that goes up with about the square of the radius. Where if it's thinner along the cross section, that makes it rotate, but longer, it doesn't increase in the same rate for how hard it is to rotate. And a lighter object already is easy to rotate, and rotating it while you're pounding it in can give you many advantages. For example, one of the advantages that it could give is that rotating it can help it turn like a screw or something better into the soil and make it be able to penetrate even deeper. It can save energy. It can mean the impact on the bar has to be less to go as deep, so you don't need as powerful equipment. Or that the equipment doesn't break the stuff apart as much, making it also free to rotate a little more with a device. Then when you hit it, it rotates a little bit, has ability to slip. And rotation one means that it's less likely to get damaged as much, the bar as it's getting pounding in. Or it could be used less energy, again, to rotate it without using any actual rotation mechanism. I'm just saying that the grip lets it rotate. Another huge advantage of this whole system is that when you have more of these things in the ground, it's less likely that any one of them will fail. I mean, that enough of them will fail that the whole thing will break. So you have more backups. And each one that fails, it's not as significant, and you have more time to fix it. Also, it's easier to, once you're doing it many times, it's more easy that you'll notice a problem. If you pound in 30, then you notice the problem that you only notice once in 30. Then if you pound in half and you just don't notice it. And the more practice with the system, because you're doing it more often, the more practice you get at noticing these problems. A more out there thing that I want to put out is that some of these systems, if you put electricity for carbon nanotubes and carbon composites, oftentimes you can tell how structurally sound they are, or are they wearing and tearing, because the electrical resistivity changes. Sometimes if they have sometimes they have something called a piezoelectric effect, where they produce current if pressure or vibrations, and that can all give you monitoring of how sound your structure is, so a warning before there's a failure, so people can act a lot faster. Or you can use it to give you warnings more while you're doing anything about how much it's compressing or how it's handling the soil, so you can make better predictions for your building while you're constructing it, or know that something it's not safe, or you need more. Or you can use it to figure out the best placement of the rods by monitoring the soil better underneath the ground. And then you can figure out better, should you space the rods more or less out? Should you not use a grid pattern, because usually assume stuff like a grid pattern is the best pattern, or some other simple pattern, but depending on the soil composition and how it varies, it might not necessarily be always the best pattern. There might be a better pattern that for that specific one. Again, subsurface monitoring, you can actually send out little waves by putting electrical currents, the opposite of before, where I said it makes vibrations turn electrical ones, and you can measure the conductivity of soil to give you some parameters about the stability of soil. You can send in sonic waves deeper into the soil, and the deeper you send in if you send in sonic waves deeper into the soil, you can help use the sonic waves to actually monitor soil. You could use this as antennas to help do ground penetrating radar, and send out radio waves to map the subsoil. And all this can help you make better models for future buildings too, by understanding soil chemistry and stuff like that, and for the building you're making, and figure out better placement of the wards. Another thing is that CNT and carbon composites in general are a lot more durable with chemical weathering and so on. So that is a huge advantage with how long it's going to last. But it goes beyond that simple durability mark in that it also has, the lower you put it in some ways the more durable it can be, because the less likely to hit subsurface water and stuff like that will corrode it, and less of it you have to protect as much from subsurface water with drainage and stuff. So you have that durability increase. Now for some more outlandish, supposedly, ideas. One is that certain carbon nanocomposites can safe sit under temperature, stress, magnetism, certain electrical inputs, or some combination, sometimes chemical. So maybe you could shape shift it to help it go into the ground better by making itself get bigger and longer, so it pounds through the ground a little bit like that, so it turns in ways to like latch on. Maybe have it bend a little bit once it's in the ground, so it hooks into the ground more. You can think of a variety of ways. Maybe it goes from thinner to thicker, so it grips the soil better at different points, or that so you pound it in thinner, then it gets thicker. Once you pound it in a certain amount, then you pound it in more. It's like making an initial hole that's smaller. That's more out there, but something to consider, and I don't think it's ludicrously out there either. Another idea is that if you make a salt tube that you pound in, you could actually pump in stuff with a tube, pump in composite that then hardens deeper down, and kind of make a branched out bread that's even lower down. This, again, is one of those more out there ideas, but I wanted to put it out there as something to think about. You could either would have to be self-hardening, use chemical hardeners, so you have to put in one chemical and another chemical, or you would have to do it with a lot of electricity because this stuff is conductive, or you would have to find some way to heat it up a lot. You could transmit electricity down these piles, or use intense electromagnetic radiation bursts like radio waves that then make the piles act like antennas. Maybe that's more efficient if the ground really does let a lot of electricity in. I would have to think about that. I do not know. It's also another advantage of this whole system that's back to more of the normal things, and I'm going to delete some stuff so it's a little easier to see, is that if something goes wrong with any of the things, it is easier to bring up one and replace it because you have a lot more backups. So that means that in some ways, security for this whole thing is a lot better. I apologize, I made it worse, the screen. And also, if it's thinner, it might be easier to pull up to some extent. Now, you're also gripping the soil more, so it depends. It might be easier to pull up in chunks, and one way I would see of doing it is to drill out some of the center of the material. Then it collapses more easily once you drill out the center, and then you can bring it up. Another practice that this will help is that it'll just give you more practice with the system. And more practice means that you'll get better at making this system, because you're just doing a lot more and you're making a lot more of these, so you end up making this technology better. A future more fancy one is that if you know more about subsurface stuff, you can make these piles have different compositions in different ways, as along the length and radially and sideways, and that way it could be flexible and turn in the soil in different ways to either grip the soil better or reach parts of soil that are more, how would I say it, better, or displace the forces in a better way. Just an idea. Another idea I have, another advantage of the system, if this whole system is lighter, you can pound it better, and it's going to accelerate more fast. And that acceleration can really help suffer through soil. Now the force is the same, but acceleration is more. And what that means is that it's more of a shock to the soil, so that shock, it's the difference between staying on something and then suddenly hitting with a hammer. Another one that I want to bring up here for kind of the final thing is, this will let us make taller ones, which means that we can grip the whole structure more lengthwise when we're pounding it in slowly in the beginning, which can lead to more stability for the pounding, more control for the pounding, and it also might make it safer for the pounding, but also we don't have to put as much force just at the top of it while we're hitting it, which means we can actually make it weaker overall for the same amount of force applied and the same amount of pounding pressure, without having to worry about the whole thing just breaking on us. I hope you found this interesting. Please like and subscribe. It really helps the channel out. I'm trying to reach 1,000 subscribers in a year and 4,000 watch hours, which is really hard, but with your help, I think I can do it. Also, if you have any ideas for future videos, comments, or suggestions, please leave in the comment section below. Again, thank you very much. Goodbye.